Pluto has a unique influence on the cosmos, as its orbit intersects with that of another planet. This tiny planet, positioned at the outer reaches of our solar system, continues to astound astronomers. Recent findings suggest a potential interaction with Neptune, raising alarms among analysts and space enthusiasts alike. Prominent figures such as Neil deGrasse Tyson and Michio Kaku have expressed concerns about the implications of this cosmic event. But how did Pluto end up on a collision course with its neighboring planet? And what might the consequences of this cosmic encounter mean for life on Earth? Join us as we explore the unexpected implications of Pluto's potential impact with Neptune and the concerns this phenomenon has raised among experts. Once classified as a planet, Pluto underwent a redefinition, becoming known as a dwarf planet due to its peculiar orbit. Despite this reclassification, Pluto continues to fascinate the astronomical community. Ongoing worries from esteemed scientists like Tyson and Kaku highlight the possibility of Pluto's trajectory intersecting with Neptune's, suggesting an impending gravitational interaction between the two celestial bodies that could have significant ramifications for Earth. Pluto's journey around the Sun is noteworthy for its unique characteristics within our nearby planetary system. Its orbit is extraordinarily elongated, taking an extensive amount of time to complete a single revolution since its discovery in 1930. In fact, Pluto has yet to finish a full orbit around the Sun. Adding to its mystique is the highly elongated shape of its orbit, which diverges from the more circular orbits of the major planets. Moreover, Pluto's orbit tilts 17 degrees from the ecliptic plane, giving it a more extreme inclination compared to other planets. The combination of Pluto's unusual orbit and its inclination introduces layers of complexity to its orbital pattern. One particularly intriguing aspect is its occasional intersection with Neptune's orbit. For about 20 years during each orbit, Pluto ventures closer to the Sun than Neptune, defying expectations based on their relative positions in the solar system. Examining Pluto's orbit reveals that it is not circular but rather an elongated ellipse. This unique shape leads to significant variations in Pluto's distance from the Sun over time. At its closest approach, Pluto is about 30 astronomical units, AU, away from the Sun, while at its farthest point, it reaches over 49 Australian dollars, twice the distance of Neptune from the Sun. Additionally, Pluto's orbit is inclined compared to the orbits of the major planets in our solar system. This inclination not only adds complexity to its orbit, but also plays a crucial role in its interactions with other celestial bodies, particularly Neptune. When Pluto crosses Neptune's orbit, the gravitational forces between them influence each other, altering their trajectories over time. This intricate dance between Pluto and Neptune underscores the dynamic nature of our solar system. Although Pluto was once regarded as a solitary wanderer in the outer reaches, its periodic encounters with Neptune highlight the interconnectedness of celestial bodies, each exerting gravitational influences that shape the orbits of others. Recent advancements in observational technology have enabled astronomers to track Pluto's movements with greater accuracy. This has led to a deeper understanding of its orbit and the potential implications for the stability of the outer solar system. While the likelihood of a direct collision between Pluto and Neptune remains low, the possibility cannot be entirely dismissed, prompting ongoing observation and study by the astronomical community. Despite its small size and remote location, Pluto continues to capture the attention and interest of researchers and enthusiasts alike. A key question arises: why hasn't there been a collision between Pluto and Neptune? The answer lies in the gravitational pull of other planets. Astronomers began studying Pluto's orbit shortly after its discovery, and its path puzzled them. Unlike most planets that lie close to the same plane as they orbit the Sun, known as the ecliptic plane, Pluto stands out with its steep inclination and elongated orbit. This mystery deepened when researchers realized that Pluto's orbit intersects with Neptune's. Despite these complexities, Pluto's orbital pattern remains stable, illustrating the intricate mechanics of space. Understanding how the three celestial bodies, Pluto, Neptune, and the Sun, interact gravitationally is a significant challenge. It's akin to predicting where they will go based on their starting positions and the gravitational forces they exert on each other. For Pluto, this challenge reveals how its orbit, Neptune's orbit, and the Sun's gravitational effects work together, incorporating concepts like asymptotic libration, scope libration, and the ZK effect. These ideas help illuminate the dynamic interplay of gravitational
impact
between Pluto and Neptune could present significant challenges for our entire solar system. Such a collision would be a remarkable and dramatic event, releasing a tremendous amount of energy and potentially causing fragments of Pluto to scatter into space, possibly colliding with other planets and moons. Neptune could also feel the effects of the impact, leading to alterations in its orbit. The esteemed theoretical physicist Michio Kaku believes that if Pluto and Neptune were to collide, it would be a fascinating opportunity for scientists to gain insights into the dynamics of our solar system. Kaku acknowledges that while the probability of such an event occurring is extremely low, the knowledge gained from studying such a unique occurrence could be invaluable. He emphasizes that this research would not only enhance our understanding of planetary mechanics but also provide deeper insights into the formation and evolution of our solar system. Kaku advocates for continued monitoring of Pluto's orbit to ensure we are prepared for any unexpected changes as our observational technologies advance. He argues that we are consistently discovering new aspects of our solar system that challenge our existing knowledge. Despite the low likelihood of a collision, he calls for ongoing research and vigilance, as even small changes in the orbits of celestial neighbors can have profound implications for our understanding of the universe. To fully appreciate the intricacies of Pluto's orbit, it is crucial to understand the various forces at play within the solar system. The gravitational influence of other celestial bodies, particularly the gas giants Jupiter and Saturn, also impacts Pluto's orbit. These massive planets exert significant gravitational forces that can subtly alter the paths of smaller objects like Pluto, illustrating the interconnectedness of the solar system. Even distant bodies can affect one another's orbits through gravitational interactions. Jupiter's immense gravity, in particular, can create ripples in the orbits of neighboring objects, sometimes altering their trajectories unexpectedly. In addition to gravitational interactions, the presence of other trans-Neptunian objects, TNOs, and Kuiper belt objects, KBOs, adds further complexity to this dynamic. The Kuiper belt is a region beyond Neptune filled with various icy bodies and dwarf planets, whose gravitational influences can contribute to the disturbances in Pluto's orbit. Studying these interactions helps scientists understand not only Pluto's path but also the broader structure of the outer solar system. An intriguing aspect of Pluto's orbit is its interaction with the solar wind, a stream of charged particles released by the Sun. Despite being far from the Sun, Pluto's atmosphere is still affected by the solar wind. When Pluto's orbit brings it closer to the Sun, its atmosphere can expand due to increased solar radiation, making it more dynamic. This interaction is part of what makes Pluto such an interesting subject of study, as understanding how its atmosphere responds to solar changes provides insights into how distant celestial bodies interact with their surrounding space environment. NASA's New Horizons spacecraft, which flew by Pluto in 2015, gathered a wealth of data that continues to shape our understanding of this distant world. The mission captured high-resolution images and collected various measurements of Pluto's surface and atmosphere, revealing fascinating features such as vast ice plains, towering mountains, and possible signs of cryovolcanism. These discoveries have transformed our view of Pluto, showcasing it as a dynamic and geologically active world rather than a static, frozen relic. The implications of Pluto's complex orbit and its relationships with other celestial bodies extend to our understanding of celestial mechanics. Investigating these interactions contributes to the broader field of dynamical astronomy, which explores how objects move under gravitational influence. By examining the intricate movements of Pluto, Neptune, and other solar system bodies, researchers gain insights into the principles governing orbital mechanics and stability. This knowledge is essential for predicting the future movements of celestial objects and understanding the long-term evolution of planetary systems. Studying objects like Pluto is also crucial for planetary defense. While Pluto itself poses no threat to Earth, understanding the behavior of small bodies in the solar system aids scientists in developing strategies to monitor and mitigate potential hazards from other objects. The principles learned from studying Pluto's orbit can be applied to track near-Earth objects, NEOs, and forecast their future trajectories. This work is part of a larger effort to protect Earth from potential impacts by asteroids and comets. The scientific community remains vigilant in monitoring Pluto and other distant objects. Future missions and ongoing observations will continue to refine our understanding of Pluto's orbit and its interactions within the solar system. Upcoming missions, such as potential explorations of other Kuiper Belt objects, will provide additional data that could reveal more about the early solar system and the evolution of planetary systems. Beyond its scientific significance, Pluto's narrative also underscores the importance of public engagement with space science. The reclassification of Pluto as a dwarf planet sparked widespread interest and debate, demonstrating how scientific discoveries can captivate the public's imagination. Educational initiatives and outreach programs focused on Pluto and similar celestial objects help foster a greater appreciation for the wonders of the universe and inspire future generations of scientists and explorers. The exploration of Pluto's orbit and its potential interactions with Neptune offers valuable insights into the dynamic nature of our solar system. By continuing to investigate and monitor these distant worlds, scientists enhance our understanding of celestial mechanics, planetary evolution, and the broader cosmic environment. Ongoing research into Pluto and its interactions with other planets highlights the complexity and interconnectedness of the solar system, revealing a universe that is both captivating and ever-evolving. Scientists are tackling the fascinating astronomical puzzle of how the unique libration of Pluto is crucial for maintaining the stability of its orbit. When Pluto crosses Neptune's path, it typically does so at about a 90-degree angle, which prevents any potential collisions. This libration ensures that when Pluto approaches Neptune or other large planets, it remains well out of their trajectory, reducing the likelihood of an impact. The phenomenon of libration, named after researchers von Zippel and Lasker, helps explain why Pluto's orbit appears eccentric yet remains stable over time despite the chaotic nature of space. Specific patterns and principles act like glue, keeping Pluto's orbit consistent and preventing crashes with Neptune or significant changes in its path. The concept of orbital chaos illustrates how a celestial body's orbit can be extremely sensitive to its initial conditions. Pluto is a prime example of this. Even small variations in its position or velocity can lead to significant alterations in its orbit over time. Scientists utilize sophisticated simulations to understand Pluto's movements in space. These simulations employ complex mathematics to reveal how Pluto interacts with other celestial bodies, such as Neptune. By making slight adjustments in these simulations, astronomers can observe how minor changes can influence Pluto's orbit. Research from the late 1980s uncovered something intriguing about Pluto's orbit. Despite factors that should keep it stable, Pluto's path can still be unpredictable. Even a slight difference in its starting position or speed can lead to substantial changes over many years. Nevertheless, Pluto's orbit remains stable for extended periods, on the order of billions of years. This suggests that although Pluto may seem chaotic, its journey around the Sun follows certain consistent patterns. Predicting the future trajectories of planets like Pluto, which have irregular orbits, is challenging. The dynamics of these systems are so complex that it is difficult to ascertain what will happen over the long term. Simulations help provide insights into potential future scenarios, but they also demonstrate the limits of our predictions. Accurate initial conditions are crucial, as even minor errors in simulations can lead to vastly different outcomes, making precise forecasting difficult. Understanding Pluto's orbit is essential, especially when considering the possibility of a future collision with Neptune. This knowledge enhances our understanding of how our solar system operates. Pluto's orbit illustrates how orbits that appear erratic can stabilize due to gravitational forces and how objects navigate in space. Continuous observation and study of these phenomena are vital for grasping our place in the universe. Exploring space reveals that many things can be unpredictable, and Pluto's orbit serves as a perfect example of this unpredictability. Unlike the orbits of other planets, Pluto's is more elongated, meaning it can sometimes come closer to the Sun than Neptune. This can create intriguing scenarios since Neptune follows a different orbital path. While there is a slight chance of a future collision between Pluto and Neptune, Pluto typically avoids such encounters due to gravitational forces. Gravity acts as an invisible force that draws objects towards one another, ensuring that even though Pluto and Neptune may appear on a collision course, their orbits are carefully arranged and influenced by gravity. Pluto's orbit teaches us that space is full of surprises. What seems chaotic at first can actually be a delicate balance of forces. By studying Pluto's path, scientists gain insights into the complex mechanics of our solar system. This ongoing observation and research are crucial for expanding our knowledge of the universe and our position within it. Imagine if Pluto and Neptune were to collide. It would be a monumental event that would challenge our understanding of the solar system. Despite the advancements we have made in our comprehension of space, this scenario underscores how much more we have to learn. Investigating how large planets affect Pluto's orbit provides significant insights into the workings of our entire solar system, illustrating how the positions and movements of planets can alter the orbits of other celestial bodies. Some leading researchers express concern about the possibility of a collision between Pluto and Neptune, prompting them to ponder why such an event could occur even if it seems unlikely. Neil deGrasse Tyson, a prominent astrophysicist, has intriguing views on Pluto. He believes that designating Pluto as a dwarf planet rather than a major planet like Earth is a progressive step. He maintains that we are continually discovering new information about the movements of celestial objects. Tyson regards Pluto's unusual orbit as an indication of the many unknowns that remain in astronomy. He finds the mysteries of space captivating and believes that significant events, such as Pluto's reclassification, can spark public interest in astrophysics. Tyson collaborates with other scientists to raise awareness about the potential dangers associated with Pluto's eccentric orbit. After conducting extensive research on Pluto, he is concerned that it could collide with Neptune one day.